Today we are going to see about Lambda iteration method. So already we have discussed economic load dispatch with and without losses of n thermal generating units formulation. Then we have solved certain problems. Today with the same thing solved with the algorithm we are going to see in detail. So already I've discussed just a revision. Then after we'll try to solve the problem. So in Lambda iteration algorithm, what is the step number one? Step one is to get the values of the number of units, demand, fuel cost function, maximum power the generation, minimum power generation of each generating. Say for example, in a problem, if in an example problem, if three units are given, 3 generating units are given, so you need to get all the 3 generating units data. What is the total demand? Then what is the minimum and maximum operating limits? Then what is the fuel cost function? Fuel cost function, you know, we have derived like fuel cost function. F of phi of PI is equal to AI PGI squared plus BI PGI plus CA. That AI, BI, and CA are the fuel cost coefficients. Already we have seen that, and we have solved certain problems also. So for 3 generating units, you need to take that values. That is A1, B1, C1, A2, B2, C2, A3, B3, C3, like that. For 3 generating units, you have to input the data. So this is for programming, but even though that is needed for solving the problem also. Next, the minimum and maximum operating limits for each generating unit. Say, for example, first generating unit, the minimum and maximum operating limits is 100 megawatt to 500 megawatt. Second generating unit, some 200 megawatt to some 400 megawatt. Third generating unit, 50 megawatt to some 200 megawatt. Like that, some minimum maximum operating limits is there. Limits will be given in the problem. Sometimes for 3 generating units, they will be giving, for each generating units, they will be giving different minimum and maximum power generating operating limits. Or in some other problems, they will be giving as a common, like for 3 generating units, you should not exceed this value. Some that also will be possible. So whichever it is given in the problem. So first of all, you have to read that problem correctly, and in some of the problems, only heat rate characteristics only will be given, like a H of P1, H of P2, or H of PI, like that. Heat rate fuel cost heat rate function only will be given. So if the heat rate function will be given, automatically fuel cost also will be given. So you need to calculate. We need to calculate the fuel cost function. Okay. So the fuel cost function is nothing but heat rate function that is into that fuel cost, whatever the fuel cost incurred in the first generating unit or second, like that you need to multiply. That is very, very important while doing the problem. Otherwise, simply if you solve now, if you didn't multiply that fuel cost with the whatever the values given, then the answer will come wrong. The demand will not satisfy. Answer tolerance limit will come like in, say for example, maximum power demand is 1000 megawatt. Instead of 1000 megawatt, you will be getting some 950 megawatt, or more than 1000, sometimes 1050 megawatt, 1030 megawatt, like that you will be getting. That is fully wrong only. Only 0 marks will be given, even though if you solve the full problem. Okay, so you have to very, very careful while selecting the data. First of all, read the question. Don't blindly copy the question in your paper. Anything for an assignment problem or in exams, whatever the problem may be asked, don't blindly solve the problem. First, read the question fully. Then after that, proceed. Okay. So next, this is the step number 1. These data we got. What is the step number 2? Step number 2 is assign the initial values of lambda. Assign the initial values of lambda. What is the formula for finding out the lambda? Like we derived this. Okay, no need to memorize. We derived. If you're finding any doubt, you go to the previous class and see this, how the lambda is being derived. Okay, so if after solving, like lambda is equal to PD. PD is nothing but power demand. PD plus summation I is equal to 1 to n. N is nothing but number of generating units. Okay, number of generating units incurred in that particular dispatch, for some period of time. And next is bi divided by 2ai, so the whole divided by summation I is equal to 1 by 2ai. So the problem, say for example, for 3 generating units, the fuel cost function is given. So the first itself you mark what is a1, b1, c1, like, okay, based on the, the general formulation. Sometimes the fuel cost function ai pgi squared plus bi pgi plus ci. Okay, sometimes in the problem the question might be reversed. They will be starting with ci, then bi pgi plus ai pgi square, like that also will be given. Sometimes differentiation like dfi divided by dpa, that also will be given. So you have to study carefully what is being given in the problem. Okay, so sometimes reverse ci plus bi pgi plus ai pgi square, like that also will be given. So first you need to mark which is C1, which is B1, which is A1, like that for 3 generating units, whatever, say for example 3 or 2 or 10, whatever the generating units is being given in the problem. First you mark the fuel cost coefficients correctly, then you proceed. Sometimes as I said, like constant will be given first, that is ci will be given first. So in that scenario, if you solve blindly, what you will do is ci bi a, instead of ci you will be taking that value as ai, instead of ai you will be taking as ca. So if you solve, the entire problem will be wrong. Sometimes the lambda might be very more, and your pgi might be of instead of demand is only 1000 megawatt, it will come like 10,000 megawatt, like that, 10,000 megawatt, 20,000 megawatt, 1 lakh megawatt, like that it might come if you wrongly take, and if you simply proceed with the problem. So you have to very careful while doing that problem. So here, what is the formula for computing the lambda? Lambda is nothing but PD plus summation I is equal to 1 to n bi divided by 2a, the whole divided by summation I is equal to 1 to n 1 divided by 2a I. Okay, so here you have to very careful in this thing. So this is whole divided by. Sometimes general mistake what you guys will do is you'll just divide these two terms first. Okay, then from that answer you'll be, so this is whole divided by. So unknowingly what you will do is just you put this denominator like the, okay, after this, and you will do all this calculation, and you will plus this whatever the value you're getting, you'll just sum up this value with the demand. So in that scenario also the answer will be getting wrong. So you should be very careful while doing this. Simple only, but you should be very clear in solving the problem. Next, step number 3. What is the step number 3? Compute the PGI using incremental fuel cost. Incremental fuel cost. This also already we have seen in the previous class. Once you verify the previous class, how to calculate the PGI. Okay, no need of memorizing all these terms. So PGI is equal to lambda minus bi divided by 2ai. You can easily derive also. Go to our previous class. For I is equal to 1 to n. Okay, so this is the value of PGI. So first we have calculated lambda for three generating units. Like say for example in the problem n is given as 3. So for 3 generating units you have to add, and you will be finding the lambda. Here after this this is PGI. So I is equal to 1 to n. So I is equal to 3. Say for example I is equal to 3 means, so you have to calculate PG1, PG2, and PG3. Okay. So in that thing you need to calculate. Next, so always you need to write this first, write this like formula, then you need to proceed. So if you forgot this formula, just derive, that's all. Only 2 steps, just derive and directly go with the formula. Next, step number 4. If the computed PGI value satisfies the operating limits, okay, if the computed PGI value satisfies the operating limits, then the optimum solution is obtained. Okay, so if the optimum solution is obtained, stop the procedure, everything, stop the algorithm, no need to proceed further. Otherwise, you have to go to the next step. That is, whatever the generation that is being calculated, that should be within the minimum and maximum operating limits that is given in the problem. Say, for example, for 3 generating units, 3 separate minimum and maximum operating limits is being given. So whatever the value we found out here, that should be within this minimum and maximum operating limits. Okay, so then if it is satisfies everything that is after calculation, then demand also satisfies, then stop the procedure there itself. No need to proceed further. And already, as I already said, the tolerance limit, how much the tolerance limit? Plus or minus 5% only allowed, tolerance limit. Okay, so if you go beyond the 5%, then the problem is wrong. Okay, instead of, say, for example, 1000 megawatt, you can calculate like 999.5 and above is good. If 999.9 is very good. Okay, if your answer is coming like 999, while calculating the demand, if your answer is coming like 999.99 like that, it is very good. Then 999.678 and all good. So you should only plus or minus 5% only. Okay, plus will not come, but 5% tolerance, you can, it is acceptable in the problem. Otherwise, it is wrong. Like that's why I said after decimal, don't round off. Take 4 digits after decimal. Whatever the value is coming, even the data and everything, whatever the after calculation, after decimal 4 digits, if you take, automatically the tolerance limit is it will be like only 1%. It will, okay, 999.96 999.95 megawatt, like that it might be coming. Next, if it is not satisfied, say for example it is not satisfied, you need to go to the next step. What is the step number 5? If PGI violates the operating limits, if PGI violates the power operating limits, then fix the generation at its respective limits. Okay, so say for example, if PGI, whatever the calculated value is less than PGI minimum, less than PGI minimum, then fix PGI is equal to PGI minimum. If PGI is greater than PGI maximum, then fix PGI is equal to PGI maximum. I think already we have done one problem. If you go through our previous classes, already we done a problem, same problem, without following this algorithm. We have solved that time. But just to differentiate how complex with the algorithm, without the algorithm, how complex it is. For that, just to differentiate, why what I did is I have solved that problem previously itself. Now the same problem we'll try to solve with the algorithm. We'll see how much minutes you are saving, how much time you are saving for solving the problem. Okay, so this is the condition. Like PGA violates its operating limits, then fix the generation to its respective limits. Next, step number 6, redistribute the remaining system load PD, okay, by using this formula. Okay, so after this, what we have to do is PD new is equal to, you have to find out the new demand. Why? Because we fixed the generation. No, we fixed the generation. We don't know. Okay, we just fixed the generation. If it is violate, say for example, in that problem, in previous problem, we have seen already, like minimum value instead of 400. Sorry, instead of minimum value, I think 50 megawatt. it has come like some 30 megawatt like that. It has come. So what we did is it is violating the minimum operating limits. It is going beyond this minimum operating limits. So what we did is we fixed that generation to minimum value. So minimum value there in the problem, I think it is given like 50 megawatt, I think so. So what we did is we fixed that value to 50 megawatt. Okay. So if and in that same problem, one generating unit, I think first generating units violates its maximum operating limits. Maximum operating limits. That is, instead of 200 megawatt as sorry, instead of 400 megawatt, it violates around. It has coming like 500, like 450 or 500 megawatt. So it is violating its maximum operating limit. So what we did is we fixed that value to its maximum operating limits. Okay, so that is that has 500 megawatt. So what we need to do is we have to fix that value. Okay, that's what this step. Next step number 6. What is the step number 6? Redistribute the remaining system load by using the formula. That is PD new is equal to PD volt minus sum of fixed generation not satisfying the operating limits. What are the say for example in a problem, 3 generating unit system problem. Say for example, first generating unit and third generating unit not satisfy the operating limits. So what we need to do is we need to sum the fixed generation not satisfies that operating limits. Okay, so say for example, what we did, like a PG1 also not satisfied, PG3 also not satisfied. I think PG1 we fix it to, say for example, we fix it to 400 megawatt. Then PG3 we fix it to some 50 megawatt. So what we need to do is we need to sum up this values, that is 400 plus 50. So 450 megawatt. So 450 megawatt we need to take over here. Okay, say for example, PD volt demand value is 1000 megawatt plus sum of the fixed generation is 400 plus 50, 450 megawatt. So what is the PD new? PD new demand is equal to 1000 minus 450. 1000 minus 450. Okay, so 1000 minus 450 is around 550 megawatt. That is the new demand. Like that you need to take. Okay, I'm telling just an example. In the problem, whatever the value is given, that you need to take. Next, step number 7. Step number 7, compute new lambda new using the following equation. Remaining generation using the following equation. What is the formula for lambda new? The same formula. Lambda new is same formula. Okay, lambda new is equal to PD new. Instead of PD, here PD new. PD new plus summation I is equal to 1 to n bi divided by 2ai, the whole divided by summation I is equal to 1 to n 1 divided by 2ai. Okay, so that we need to calculate. That is only for remaining generation. Okay, so not the fixed generation, because fixed generation already we have calculated the new PD new value. Say for example, in a problem, first generating unit alone is not satisfying the first generating units alone not satisfying the, say for example, maximum operating limits. So we fix the maximum operating limits as some 400 megawatts, say for example. So whichever the value not satisfied, that value alone you need to take in the new lambda value. Okay, while calculating new lambda value, you need to neglect that first generating unit alone. Why? Because we already calculated PD new value over here. Okay, so no need to add PD new value. How we calculated? PD new is equal to PD volt minus sum of fixed generation not satisfies the operating limits. So say for example, in our problem, only first generating units alone not satisfies the operating limit. So we need to neglect this. So we need to neglect, and only here, only we have to take only to second and third generating unit alone for this value. Okay, so B2 divided by 2A2 plus B3 divided by 2A3. Like that alone we need to take. And similarly here also, in this step also, what we have to do is we have to neglect the first generating unit. That is 1 divided by 2A1 we have to neglect. only 1 divided by 2A2 plus 1 divided by 2A3. That alone you need to sum up and you need to proceed further, because here we are adding PD new value. Okay, already we fixed the generation and we are calculating lambda new value. Okay, that you need to do very careful. Sometimes by mistake, if you calculate for 3 generating units, again the lambda value will come some different value. Again, if you solve that problem, it will not satisfy again. Further, you will be proceeding this algorithm 5 times, 6 times also, it will not satisfy. Again and again, it will come the same value. That is, it will not satisfy the demand. Again, you need to calculate PD new. Like that, this loop will continue. Okay, this you need to calculate more and more. It will never satisfy the demand. Like that, it may happen. Sometimes it may, after 10th iteration, if you're doing wrongly, after 10 iteration or 15, 20 iteration, sometimes it is possible, like minimum it is possible, not exactly it will satisfy the demand. Some with some tolerance limit, it might be, it may satisfy the demand, but the answer is wrong. Okay, while calculating lambda new alone, you have to carefully do, and you have to keep this is in the mind. Next, so like lambda new we calculated. After that, similarly we need to calculate PGI new also. Okay, PGI new also. What is the formula for PGI new? So sorry, this is wrongly given. So PGI new is equal to lambda new minus BI divided by 2AI. Lambda new minus BI divided by 2AI. So whatever the value, not say for example PG1 we already fixed, no, in example I said now PG1 already I fixed. So we need to calculate PGI new, that is PGI PG2 new and PG3 new. That alone you need to calculate. That's all. Next, check whether the optimality condition is satisfied or not. This optimality condition already we have seen in the first class itself. We have derived this conditions, optimality conditions, while starting. Okay, so if you go through your previous thing, that is, if you go through the economic load dispatch of n thermal generating units without losses, we derive this optimality condition, 3 conditions. So in that condition, what is the DFI divided by DPGI is equal to lambda nu for PGI minimum less than or equal to PGI less than or equal to PGI maximum. Then if DFI divided by DPA is less than or equal to lambda nu for PGI is equal to PGI maximum. If DFI divided by DPGI is greater than or equal to lambda nu for PGI is equal to PGI minimum. Next, if this condition satisfies, then stop the procedure. Okay, this condition satisfied, then stop. Otherwise, release the generation schedule fixed at PGI minimum or PGI maximum of those units not satisfies the optimality condition. Include these units in the remaining units and modify the new power demand. Okay, what they are really saying is, if this condition satisfied, then stop the procedure. That's all. Our problem is solved. Otherwise, again, you need to go to this step. Which step? Yeah, you need to fix the generation again. Whichever is not satisfying, again, you need to fix the generation. Okay, so again, you need to verify whether the fixed generation is correct or not. Okay, that's what really said here. Otherwise, release the generation to its fixed to its minimum or maximum operating units of those units not satisfies the optimality condition. Then include these units in the remaining units and modify the new power demand. Again, you need to calculate the new power demand. Okay, again you need to fix. Again, you need to calculate the new power demand. What is the formula for calculating new power demand? That is, now we can take it as PD new 1. Okay, because already we calculated PD new. Now PD new 1 or PD new dash. So whatever the notation you can keep just to differentiate. So I'm taking this PD new 1. So PD new 1 is equal to PD new, whatever the value. Say for example, we calculated, no, PD new. Say for example, it is coming like 550 megawatt. Like that we calculated in the problem, no, like some example I said some 550 megawatt. So what you need to do is 550 megawatt plus sum of fixed generation not satisfying the optimality condition. So in this condition, second time, whichever the condition is not satisfied, you need to fix that generation. So that you need to sum up and you need to add over here and go to the step 7. Step 7, and again you need to proceed. Like you need to find out lambda new, again PGI new, and again you need to proceed this condition. Again you need to check this condition, optimality condition. If it is optimality condition satisfied, then again you can stop the procedure. Again you need to, if suppose this case also not satisfied, again you need to proceed further. Like that you need to proceed. You need to proceed the steps until otherwise the demand is satisfied, and as well as minimum and maximum operating limits gets satisfied. Now I am giving you a small assignment problem to solve using the lambda iteration method. Okay, take down this problem. I will ask this problem. Now I am giving you a small assignment problem for you. You try to solve this problem with the lambda iteration method. It is very simple. 2 generating units only. Demand is 250 megawatt. You try to solve this problem by using the lambda iteration method. Whatever we have seen in the previous topic, like lambda iteration method algorithm we solved. By using the algorithm, you need to solve this problem. That is for 2 generating units. So the first generating unit F1 of P1 is equal to 1.6 plus 25 P1 plus 0.1 P1 square. Then F2 of P2 is equal to 2.1 plus 32 P2 plus 0.1 P2 square. Next, the power demand PD is equal to 250 megawatt. So here in this problem, you need to note down one. The thing is that first constant term is asked. First, what is the constant term here? This is C1. What is this term? B1. This is what is this term? This is A1. So what is this term? C2. This term B2. This term is A2. So from this, so whatever the problem is given. So if the problem they are telling like solve using lambda iteration method, like that, if they tell now, so simply like that, you first of all you write the what is C1, what is B1, B2, so A1, what is C2, B2, A2, like that. First you write, then you proceed. Why? Because further to avoid the confusion. Sometimes what you will do is wrongly, while you write the problem correctly in the notebook or paper, and while substituting, you will be wrongly substituting some values, and you will be doing the same problem. Further proceeding the same problem, it will give the wrong value. Okay, even if you solve for half an hour or 1 hour also, it will come wrong only. Even if you further proceed with some 5 iteration also, it will be wrong one. So that's what you have to carefully do. So for that, once you note down the fuel cost coefficients clearly, then you further you proceed. Then you can easily solve this